So welcome everyone. My name is Michal Wojtik and I'm working in Red Hat as a software engineer. I'm working on a Deltacloud API project, so this talk will be about what is Deltacloud API, and since we recently released the major version, first major version, so I will talk briefly about that, like what new feature we add, and in the end I will talk about the future development, so what we are working on right now. So what is Deltacloud? Nice definition is it abstracts the differences between multiple cloud providers, infrastructure service providers. So in other words, it's a REST API that sits between your application and the cloud provider, and it translates everything coming from your application to the cloud API. So why another API, right? Like there are many APIs. Some of them are standard APIs, some of them just proprietary APIs cloud vendors use. So the first assumption is that almost all cloud vendors are evil, so they want your money, which is like how they operate, right? They will not give you the cloud for free, they want to charge you for using their service. And why they are evil is that they want to lock you into their service, so they don't want to make the switch from one cloud provider to another, or they will not make you easy to do it for obvious reasons, right? They don't want to lose you as a customer. So one of the things is that we call it vendor lock-in, where you are, locked into one cloud provider, and it's very hard for you as a company to switch to another cloud provider. It's hard in terms that usually you need to rewrite your application, you need to change your code, you need to adapt to the new API that the other cloud provider uses. The second thing is that they usually don't guarantee anything, so they offer the API, they add new features, they remove some features, but if you are running some critical application, right, so this for you it means downtime because your application will stop working and you need to change something in your code to incorporate these new changes or new features. I can give you an example. For example, the RefM or OBIOS project, they recently added the VM payload feature in version 3.1, which is a very nice feature. You can pass the user data into the instance. You can use this for transferring like one-time password or the URL for the database. So inside the instance, your application can read that file and fetch the database or set the good password. It's a very nice feature. We support it in Deltacloud. We call it the user data feature. But this new VM payload, it was different than before. Before we used a thing called floppy hook, which is kind of the hack for RefM, where you specify XML and you use this hook to create a floppy drive that is attached to the instance, and you can find the data there. So, and this new VM payload uses a bit different XML specification. So if you already use that, you will need to change your application to support this new feature. While if you are using Deltacloud, like you don't need to change anything because we changed it in a driver. So we are now smart enough to detect like, hey, you are running on RefM 3.1, so we will use the VM payload, or you are running on RefM 3.0, so you will go with the floppy hook. And the third one is that they suck in API design. Some of them, so like EC2 API is not a beautiful example of how the API should be done. There are other providers like vSphere, for example. If someone from you work with a vSphere API, they use a SOAP. So not everyone likes the SOAP protocol. So it's very hard to create a client tools and everything. And why you should use the Deltacloud API? Deltacloud is an open source project. It has a growing community. We are very happy for that. So we are a top-level Apache Software Foundation project. So we were in the incubator for 1.5 years, then we grew up. So we are now top level, and we basically care where the cloud providers don't, right? Like I said, like vendor lock-in. If you're using Deltacloud, you can switch from one cloud provider to another very easily. You just change the driver, or you just specify the HTTP header, and it's done. It's always the same API. And we also protect you from the backward compatibility changes, as I mentioned, the RefM, so it always works the same. So how does it actually work? So we did a real cloud abstraction. So we tried to abstract the way how infrastructure as a service cloud works. It was very hard, but we ended up in like 4 basic models. So first is the realm, which is the unit like where the instance will be run. So it means it can be a cluster in runtime, it can be a data center in vSphere, it can be a region in Amazon EC2. You know, all cloud providers use a different thing, but we always call it realm. Then you have the hardware profile, which is kind of sizing of your machine, of your virtual machine, where in Amazon it maps to the instance type. In RFM, the hardware profiles are very flexible because you can run whatever virtual machine sizing you want, right? If you want a, I don't know, like 40 gigs memory virtual machine, you can run it if you have the hardware for that. So we have the hardware profile where you can specify the CPU, how many CPUs your virtual machine will have, how much storage your virtual machine will get, and how much memory, of course. Then you can choose an image which represents the template. Basically, it's a root hard drive, it's a root partition with pre-installed operating system and with some software that is specific for the image. And then when you combine these 3 things, you get an instance, which is the realized virtual machine, running virtual machine. You can manage the virtual machine, so you can stop the virtual machine, so you can start them again, you can reboot, you know, you can do all this life cycle management stuff. And we support all these 4 models for all the cloud providers mentioned here. So yeah, we have a pretty big list of what we do support. We support them through the drivers. We call it drivers, but in other words, it's an adapter, it's a client to the backend cloud. So it's the thing that translates these 4 models and maps them to the backend cloud model, whatever it looks like. So we have the computing drivers, which is Aruba, DigitalOcean, ADC2, Eucalyptus. Recently we added Fujitsu and GCP, GoGrid. Google is a storage driver, so we don't really support right now the Google Cloud platform, or how they call it, but we just support the storage stuff, so you can stream the blobs, is a kind of key value store. Then we support OpenNebula, we support OpenStack Rackspace, RFM, Remote Hosting, IBM contributed the driver for the smart business cloud. Termark is a crippled vCloud implementation. Then we had VMware support, of course. So that is growing. Some of the drivers are written by us, so we wrote them, but some of them are contributed from the other folks, like maybe from developers from those projects, or just by some upstream guys that wants to have the driver for the service. So how can you install Deltacloud? It's very easy. Fastest way is to use a Ruby gems, because Deltacloud is written in Ruby. So you just install Ruby and you run gem install Deltacloud core. You will get everything. Or if you are a Fedora user, you can use yum install Fedora core all. It will install all the dependencies, everything, and you will get a service like a system daemon that you can start and it will work. We are looking forward for packagers for the other distributions like Debian. So if you are Debian packager, you want to contribute, you are more than welcome. Then once you install it, it's very easy to use. So if you are not using the system service, you can start it on command line, where you just run deltacloud d -i and the driver. In this case, it's EC2 driver, but you can use like RFM, OpenStack, everything. It really doesn't matter what driver you start Deltacloud with, because you can switch between drivers using the HTTP header. So you don't need to run like 10 Deltacloud instances each for one provider. You just run one, and you can switch between drivers using the HTTP header. As I said, Deltacloud is a REST-based API, and we did it as a REST service because it's programming language agnostic. If your programming language is able to talk to HTTP server, you are fine, so you can build your client and do whatever you want. We ship the native clients to Ruby, to Python, to C, Java, and there are other implementations. I saw the Eclipse plugin for Deltacloud. We have a Jenkins plugin for Deltacloud, so the community is contributing all this stuff. Or you can use old school curl command. So in this case, this is an example how you can create a new instance where you just choose the image ID, in case it's some random Amazon image ID. Then you say, okay, I want to get JSON back, I don't want to get the XML. Then you send the API key, which represents the Amazon API key and API secret, which is the secret key. This model works for all providers, so we don't need to invent any fancy authentication schemas like OAuth or something like that. You are fine with two types credentials. And yeah, this is the URL where Deltacloud is running. If you are interested, like there are many examples on our website, so you can see like with curl how you can create instances, how you can create images, how you can create volumes. So let's skip to version 1. So there are 3 main features I want to highlight. First is we add the modularity support. So now, since we are a Ruby project, Deltacloud is written in Sinatra. We are not Rails. So it's a very small, simple application. And now we use the modular style of writing a Sinatra application where you can mount the application inside your Rails application, for example, or whatever else compatible application. So you don't need to run Deltacloud as a separate daemon. You can just stick it into your application and run it inside it, which ultimately, as a consequence, create a Deltacloud as a Ruby library. So now you can require Deltacloud as a regular Ruby library and use the driver's API directly, so you don't need to run anything in Ruby development. It's a big switch because we need to rewrite like half of the code we had. So we also have new drivers. We add the OpenStack support. We had the OpenStack support before. We also had the Rackspace gem, but it was not very good. Like there was many bugs. The OpenStack API was changing a lot. So now we are stable with Essex. So we support all the features that Essex have. We are testing Folsom, but I don't expect like there are many differences between Essex and Folsom APIs. So, and we also support OpenStack, for example, we support Swift. So as I said, for Google, that you can do these key value store, you can upload blobs like big chunks of data. And you can also use it for EC2, so you can use this, how they call it in EC2, S3. So in OpenShift, they call it Swift. And with Deltacloud, you can use all these 3 in the same way, just stream the data straight to the cloud provider. We don't store anything, we just pass through the data through Deltacloud in the same way. Then we have the support for OBM 3.1. So as I said, we support this new fancy VM payload feature, and thanks to OBED, we have the user level API support, so you don't need to use the admin level API all the time. Then Fujitsu contributed the Fujitsu Global Cloud Platform driver, so we are working very highly with the Fujitsu developers. They try to very awesome. It's awesome, like it's feature full, like it supports almost everything we support. Then recently I added the DigitalOcean, which is the new hype cloud. They offer SSD kind of storage for crazy prices, so it's worth to check out. And Aruba guys contributed Aruba driver, which is some kind of Italian cloud provider. Then the most interesting part of new features are that we introduced 2 new API frontends. So far we had just one frontend, it was the Deltacloud API itself, right? It was Deltacloud standard with these 4 models. But right now we also exposed the Deltacloud exposed Amazon EC2 API. So if you already have the application that speaks to Amazon, you can replace, you can put Deltacloud in the middle of that, and you can, for example, connect to the RefM or OpenStack or I don't know, GoCreate or DigitalOcean, and you can have an EC2 API for all those cloud providers. This is done as a proof of concept. It's not feature complete because there are some stuff in Amazon EC2 API. It's not a great specification. So, for example, the hardware profiles, right? It's very hard to map the hardware profiles to the instance types because EC2 don't advertise instance types via API. They are just hard coded on the website, so you need to know them. So, And more interesting, we had support for the DNTF CME 101, which I will talk more. So what is CME? CME is a new emerging cloud industry standard, so API. CME describes the model and protocol how how the interactions between cloud provider, infrastructure service cloud provider, and the customer should look like. The focus is to achieve the interoperability between big cloud providers, between big companies, because the DNTF working group consists of the members are the biggest cloud players like Citrix, Fujitsu, HP, Huawei, IBM, Microsoft, Oracle, and Red Hat, of course, VMware. So all these companies are participating on creating this standard. So we hope it will be more adapted in the future because it's very young. Like it was released 5 months ago, the first version. So we are looking forward for adoption. Like you should see more. And just to describe what is the DNTF, maybe you don't know, but those are the guys responsible for OVF or SMBIOS standards. So it's pretty awesome organization. So how does CME versus Deltacloud work? Basically in CME, they have very similar object model, but in CME, of course, they are doing very deep abstraction, like they have many entities, basically cover the whole cloud object model. So the basic models are machine, of course, virtual machines, volumes, which is the storage API, network, which is networking API, and monitoring, which is kind of event logs and event capturing, passing. Then they have a systems, which is very complex things that incorporate all these 4 entities inside, so you can create the whole system, which describes the machines, then it describes volumes, how the volumes are mapped to the machines, then how the monitoring is enabled for some kind of machines, and in the end it describes also the networking, so how the traffic is routed between the CME, so it's a very complicated entity. In Deltacloud we don't support system and monitoring, just because we are stateless, so we don't have any database, which I'm lying right now, but we don't have any database at the time release, so we can't actually store them somewhere, and there is no other cloud provider right now in the world that supports something like that, right? So we can't map that to the existing cloud provider we support. So to describe the machine entity consists from these 5 models. Machine configuration kind of mapped to Deltacloud hardware profile. So it describes like the sizing of the machine, like how many CPUs, how much memory, stuff like that. They have the machine image, which maps to the Deltacloud image, which basically it's a root partition with software description packages, how to boot the image and stuff. Then you have the machine admin. In Deltacloud we call it key collection, which describes the credentials that are used for connecting to that machine. So basically it can be a username, or it can be the PAN key or SSH connection, whatever. And then you have a machine template, which is a combination of all these 3, but it's just metadata. So you can create a machine template, and then from this machine template you create the machine. You can skip the machine template, you can just use these 3 to create a machine. So machine template is really like a description how it should look like in the end. So the CME features are, it's very extensible API, so basically the valid implementation is that you don't implement anything, just an entry point, and you are CME compatible. You don't need to implement all of the entities, you just implement those that your provider support or you support. There is also built-in extensibility mechanism called resource metadata, where you can just extend the API with stuff you want. And yeah, the specification covers almost everything in cloud, so it's very good. The Deltacloud with CME, we support it, so you can start Deltacloud, you just add this -f CME parameter, and Deltacloud will expose the CME on this URL, so you can try it out. You can use the CME with all the cloud providers we support, so you can have a CME for EC2, you can have a CME for OpenStack. So doesn't matter. This is example for example, how to get the details of the machine. More examples are on Deltacloud website. They really suck in how they write documentation, so now I think we are the best source for the examples. So if you want to get familiar with CME, I recommend checking out our website. And this is what you get back. Yeah, it's pretty scary, but yeah. Basically, it has a name, description, properties are user stuff, so you can put something that you want for the machine, some additional information, some metadata. Then you have a real, and this is actually not part of the official specification. This is the resource metadata we add in Deltacloud, because in CME there is no way how to say this machine belongs to this data center. For some reason they don't have any standard, and we thought it's important to know like where your machine is running. So we add the real. Then you have the state, target, how many CPUs, how much memory, what the disks, so what disks are inside the virtual machine, what volumes, if there are some additional volumes attached to the machine. It also exposes the operations you can do, so you can restart the machine, you can stop, you can capture, you can do a snapshot of the virtual machine. All these operation works through the Deltacloud drivers. So if you, for example, restart, we actually translate that through Deltacloud driver to the EC2 restart operation. So, okay, so what we are doing right now, we want to improve CME support with more entities. So we want to try to implement the system or systems template, which is a very complex thing. So for that, we need to add a database to Deltacloud, but it will be just as a proof of concept. What is more important, we are currently working on a networking API because we don't have it in Deltacloud right now. So we want to map, we want to find some common partner in all cloud providers we do support. So for OpenStack, it will be Quantum. For EC2, VPC. For vSphere, we don't know yet. For RefM, we don't know yet. So we are kind of in the phase of modeling how this should look like. The same for the storage API. We want to be, right now we support storage volumes, but it's very like basic support, so we want to extend that. And then we want to add more drivers. As I say, Google Compute Engine is the one on the list. Then we have currently shielders from CloudStack working on a Deltacloud driver for CloudStack. And if you want to add your service to Deltacloud, just feel free, send patch, something like that. It's very easy to write a driver. Just you need to implement a couple of Ruby methods. You're done. We are open for discussion about adding more API frontends. So for example, the OpenStack frontend, so we can expose the OpenStack API for, let's say, OVIRT, right? So we are open for discussion. And in the end, we want, this is a very long-term goal. We want to have a stateful Deltacloud where you can get something like a webhook. So when you start the instance, it will notify your client application that the instance is running or something like that. So you don't need to query the API, all the time. This is something we are working on. Okay, so this is my email. For the real-time questions, you can use the RC. Usually there is someone that will respond to your questions. Patches are more complicated and sophisticated questions. You can use the Deltacloud mailing list. I use this tool for presentation, so don't ask me what is this presentation written. So, any questions? Yeah?
How do you deal with differences? I mean, tiny things like user data, SSH keys.
Yeah, it's very hard. Like we try to avoid implement everything for cloud provider. We always try to find something common. So if there are some special features, we just don't implement them and we keep that to the client to implement them themselves. But it's still like if you still use Deltacloud, even if you use just the basic models, it's less work when you switch to other cloud providers to find some matching feature. Right?
But if I would, you mentioned Amazon, the way to access it is to specify my SSH key.
Yes.
If I were to do that using Deltacloud API,
right.
There's no way to...
There is. We have the extended collection. These four models are the basic models. They work for all cloud providers. But some cloud providers define extra collections. For Amazon, for example, you have the security group, so you can create a security group. You can also create a SSH key, so you get a 10 key back, so you can connect to the instance. You also we also have the firewalls collection for Amazon. We also have the what's called all balancers collection, so you can create all balancers. But those collections are not supported for all cloud providers, right? Because there are no SSH keys for GoGrid, for example. So we just don't advertise that collection. Okay. Yeah.
Do you have a link with your cloud API from the CDMI?
You mean a storage API? Yeah. For CME, yeah, we try to map that to our storage volume support that we have in Deltacloud right now. And to be more compliant with what we have, we want to extend it. That's why I had it on the side. Like, this is a future plan. Like, we are currently evaluating what can we do with storage for different cloud providers. So what they have in common, what we can abstract. So. And if we will discover that model, we will implement it for CME. Any other questions? Okay.
How are you getting extra layers of abstraction between the primitives, the unified and the general concept of unified an instance and a realm? For instance, in Amazon, they have this thing called a reservation that sits in between the realm and the instance. Do you ignore that?
Yeah, we just ignore that.
Okay.
Yeah. Yeah, like there are some sacrifices you need to make when you are doing cloud abstraction. So for example, there is a fork library in Ruby, and it's not a really cloud abstraction because they try to implement everything, but you can't implement everything for everyone. You need to find some common pattern that works for every cloud provider, which is very hard. So we just ignore them, and if you want to use them, like you will need to write some extra wrapper, or if you can just use Deltacloud and extend the driver. It's a Ruby, so you can just monkey patch, you can add whatever you want and run it. Yeah.
What about subnets?
Yeah, we have support for subnets for the EC2. It's a different realm or something like that. I know that we have this map to the realm collection, so you can create a VPC subnet and you can attach that to the instance, or you can attach the instance to the subnet, something like that. But it's very basic support. Like, we want to do better job with this networking API, so we want to map the subnets and everything. Also, CME describes subnets, forwarding groups, this kind of models. So we want to map that to the CME as well. Okay, any other questions? Okay, so thank you. If you are shy and you don't ask your question, I will be here in the room, so just